Hey guys, welcome back. This is going to be part 2 of a hopefully only 2-part series we're doing. Just to kind of summarize what we did in part 1, we're working on a 06 Freestar, and the complaint with this vehicle is that once you run the wipers for a while, they continue running, and the radio continues to work after the key is off and out of the ignition. So kind of go back and kind of cover what we did up to this point. We took off in the radio direction first. We confirmed that he gets power from this accessory delay relay. We did some checks at that relay and found that it was being energized all of the time. So at that point, what we did is we looked at some input stuff for the smart junction block, and what we found was that the input regarding turning this relay on comes from the ignition switch. We did some voltage measurements there, paying real close attention to this black light green wire that we were on before. When we tested voltage there, guys, we had this 2.8 volts, and when we pulled that voltage to ground, the accessory delay relay was turned off and the radio shut off. The windows no longer worked. So we kind of went around that a little bit at first, and what we ended up doing were powers and ground checks on that module, and what we found that all powers and grounds on that module were good. So kind of where we left off, guys, was getting late last night, so we kind of stopped, took a break, and sort of where we left off was we were definitely concerned more with that black with light green wire coming from the ignition switch, based off the fact that we had that 2.8 volts there. We unplugged the connector for that junction block, and we took another voltage measurement there, and we didn't have anything present, guys, but the issue with doing that was we had the entire junction block connector unplugged, and there's a possibility that wherever that voltage was coming from, if it was coming from, you know, an external circuit, its source voltage may have came from that connector. So that's kind of where we left off, guys. We want to focus more on that black with light green wire and determine what's going on with it, simply because we can ground it, and this delay relay is turned off. The junction block is turning this relay off. So yeah. What we're basically going to do is we're going to get back on the car, we're going to get back hooked into this black light green wire, and we're going to do some more checks on that, and we're just going to kind of continue from there, and let's get this thing figured out. Alright guys, so we're jumping right back into this one here. And as you can see, what I've done is I've installed this piercing probe into this black light green wire. This is the circuit in question, guys. This is the one we're working on. As you can see on the meter, currently at 2.9 volts. The key is out of the ignition. The radio is still currently on. I already looked at this connector to see if I could easily release this terminal, and that doesn't appear to be the case. So what I'm going to opt to do, and I know some of you guys are going to disagree with that a little bit, but it's what we're going to do. I'm just going to cut this wire, guys. I need to determine where this voltage is coming from. So I'm just going to snip this now, and we're going to stay focused on the meter, and we're going to see what this voltage number does when I cut this. So that is cut now. The radio is still on, and we can see we have about this number floating around 30 millivolts on this thing, guys. So without a doubt, this voltage is not coming from this. It's definitely coming from this smart junction block. Let me go back to this. So tied back into this, we see this 2.9 volt number. Again, what I'm going to do is I'm just going to ground this. I don't think this is hooked up too well anymore. I found my other test light. Here it is right here. So I'm pulling that to ground here, guys. It doesn't appear that anything is happening to this when I'm grounding this. I remember before when we grounded this terminal, we were able to get the radio to shut off. Let me try this other side over here. I'm just touching this on here. So for some reason we're not receiving the same result that we were seeing yesterday, which is a little bit strange. The radio is still on. I can see that it is still on for sure. Let me see. Just wondering if I'm not making a good connection here. Let me make sure my test lights. You can see it does. Yeah, so we were grounding this terminal yesterday, guys, and this radio and stuff was shutting off, so I'm not sure why that's not the case now. But that being said, it does not appear that this voltage is coming from any sort of external source at this point, but we do still have this 2.9 volt reading here. So I want to revisit the diagram real quick, take another look just to be certain what's going on with this circuit, and we'll continue from there. Alright guys, so I'm still hooked up here, and I was a little concerned by the fact that we couldn't duplicate the results we had yesterday with grounding this circuit out and getting this radio to shut off. And I determined why that was. It was because I had the door latched. I had the door latched yesterday for some reason. I can't remember exactly why, but I unlatched that door, guys. So I'm just going to repeat that test. And you can see when I touch this test lamp to this wire and I pull this 2.8 volts down to ground, this thing is shutting this delay relay off. I'm just putting my thumb on this delay relay, and when I touch this pin, guys, I can feel this relay shutting off. We can see that voltage dropping low. While I do this, I can also see that this radio is indeed turning off. So the door latch was affecting that. Now that we have the door latch back in the open position here, we can kind of duplicate what we were seeing yesterday. So as far as next steps go with this, we need to go to the diagram, take a look at, maybe see if we can determine what sort of internal circuitry we have going on here with this black light green wire with this 2.8 volts, and let's make sure that this is something that's going to be an internal fault to this, and not something that could potentially be affected by some outside circuit. So that's coming up next. Alright guys, so what I did here was basically I went back to this power distribution diagram, and the block that we're currently looking at is this smart junction block here. And what I wanted to do with this is I wanted to determine where this black light green wire was on this diagram, to get an idea as far as what it's tied into in this unit, as well as where it comes from. We know it comes from the ignition switch, but I wanted to see what else was potentially involved here. And if we take a look here, the wire in question, the one we've been testing this whole time with this 2.8 volts, is this one right here. And it comes from off the page on this number D on this other diagram. We'll go visit that quickly. But what I can see here is this circuit is actually tied into two different places on this board here, guys. And if we follow this down, we can see that it comes to the windshield wiper motor, and it also comes to this rear wiper motor assembly. Both of these things have their own fuses internal to this board. We have this fuse number 3 here and this fuse number 7. If we follow this black light ring wire off the page, it comes over here to pin D on diagram 2. So I'm just going to shoot this thing back over, guys. And we can see I have that here. So we follow this black light green wire up, we can see that it does indeed come to the ignition switch. And we see that it can get power from two different places on here. One place it can get power is in the run position from fuse 67. Another place it can get power, if we follow this splice over, is this accessory position here from fuse number 64. So what we do know, guys, is we have 2.8 volts coming from this smart junction block. It's not coming from the ignition switch because we cut the wire. And what we did was we basically cut the wire here. If we go back to this other diagram, we just snipped this wire off here, caused an open. So we know that this 2.8 volts is coming from this area here. And to me, what it looks like is the only place external to this board that it's tied into is the windshield wiper motor, as well as this rear wiper motor assembly. So there's definitely some external circuits involved with this this wire that we're currently troubleshooting. It is not just internal to the smart junction block. And basically what that means for us, guys, is that we can't call this box yet because we have other circuits that could potentially affect the one that we're troubleshooting. So I think what I want to do here, based on the fact that we have this windshield wiper motor as well as this rear wiper motor tied into this black with light green wire via these two fuses, is I want to pull a windshield wiper circuit diagram. I want to see what exactly these two wires are doing. I mean, I know they're providing power feeds to these motors for sure, but I want to see, you know, what exactly they're doing, what exactly is involved with the internal circuitry of the wiper motors. And potentially what we're going to do is we're going to go to these two fuse locations and do some tests there, and see what we're looking at, and see if potentially maybe an issue with one of these guys is causing this very strange condition with this accessory delay relay staying on. So that's coming up next, guys. I'm going to get a diagram of this wiper system, and we're going to go over it and see what we're working with. Alright guys, what we're looking at here is I pulled a wiring diagram for this front wiper motor, and there's a little bit of glare here, but that's okay. If we look here, we see this fuse 3. This is the one we were concerned with, guys. This is the one that's internally tied into this black with light green wire in this smart junction block. So what I've done is I've just highlighted this wire all the way down to this wiper motor, and really this should only be hot and runner accessory, as we can see from up here, this little text that we have. So only in the hot or run position should we have any voltage present here, guys. And I'm just following this down, and it looks like this is providing control side feed to a couple of different relays that are internal to this wiper motor unit. Looks like we have a front washer pump relay, we have a wiper high low speed relay, and a wiper run park relay. So at no point, guys, we really shouldn't have any voltage here. We can see another power feed coming to this unit from this fuse 54. This is a power feed that's hot all the time. It's a 30 amp fuse. But kind of what I'm thinking about here, guys, is I'm thinking about the symptoms with this vehicle. This customer had two different complaints. One of them was this wiper issue. You know, you use the wiper motor for more than 20 seconds or so and the wipers stay on. You know, that's definitely a little weird. Definitely somewhat strange. It kind of points to an issue with this wiper motor, potentially based on the controls of it. Not sure. But given the fact that this wiper motor is tied into this black with light green wire, you know, going back to this other diagram here, you know, this fuse 3 coming down to this wiper motor, this is tied into the circuit we're worried about, guys. We can ground this circuit out, and this accessory delay relay is being de-energized, and we definitely had 2.8 volts on this coming in this direction. I realize I've drawn all over this thing at this point, but that's okay. So I'm definitely a little bit worried about maybe there's some sort of external power source here, and maybe this 2.8 volts we're seeing is enough to trigger something in this unit, you know, some sort of state monitor. Maybe that voltage is high enough for this smart junction block to interpret that as the key is in the accessory position, guys. I'm not sure yet, but I think really kind of what we need to do at this point is, I'm thinking the easiest thing to do is go to this fuse 3. We'll go back to this wiper motor diagram here. And we can see that this fuse is in the smart junction block here. I think we should go to this fuse, do a voltage measurement there, see if we have that 2.8 volts present, and if we do, I think what we should do, guys, is we should pull this fuse out of this thing and see if our radio and stuff shuts off. And if it does, really what that kind of points to is an issue with this wiper motor, and we're going to need to go to this wiper motor to do some checks there to see what's going on. So next stop, voltage measurement on fuse number 3. Depending on what we find there, we may also do a voltage measurement on this fuse number 7 coming from this rear wiper motor assembly, depending on the results of us pulling this fuse. So that's coming up next, guys. We're just going to go to this fuse, take a quick voltage measurement, and then we're going to remove it and see if our radio shuts off, see if our accessory delay relay is de-energized. Alright guys, so we're back in the vehicle, and you can see we're still hooked up to this black light green wire here. We have this 2.8 volts. Really what I want to start with doing here is I'm just looking on this diagram, and I'm attempting to determine where this fuse is. The one we're looking for is fuse number 3. And if we kind of tilt this thing sideways, I know you guys can't see the numbers, but I can see that it's this fuse right here. It's a 10 amp fuse, and it's going to be this one. So what I'm going to do here, guys, is I'm going to keep an eye on the radio, and I'm also going to keep an eye on this meter, and I'm just going to remove this fuse, and I want to see if we have a voltage change here. And if we do, really what that kind of points to, guys, is we have some sort of backfeed voltage issue from either this front wiper motor assembly or the rear wiper motor. And remember the symptoms, guys, this wiper motor is having some kind of weird stuff going on with it too. So I'm just going to remove this fuse and let's see what happens. Wow. Guys, we were pretty close to calling this module, and man, this is pretty crazy, to be honest. We just pulled this fuse going to the front wiper motor, guys, and this voltage went away. We no longer had 2.8 volts here. This accessory delay relay was de-energized, and if we look at the radio, it's off. Take a quick look at the windows. As you can see, they're not rolling up and down. So let me put this fuse back in, guys, and let you guys listen to this relay as I do this. Fuse in and out, fuse in. We see this 2.8 volts, fuse out, and we can hear that accessory delay relay being energized. We've got the fuse back in here just to take another look. We can still roll these windows up and down, guys. So this is pretty wild, guys, and I'm really glad that we decided to revisit this circuit, because if we had not, we would have misdiagnosed this vehicle. Without a doubt, this vehicle does not need a smart junction block. We have some sort of backfeed issue potentially from this front wiper motor, guys, and this is pretty wild. This is not something you're going to see often out in the field, but I'm definitely glad that we took a break from this thing and that we decided to re-attack this circuit, because we definitely have some sort of external circuit affecting the way that this box runs. So as far as next steps go, we need to start looking towards the wiper motor assembly. But before we do that, I want to go to the whiteboard. I had a viewer in one of my past videos say that it was the board of knowledge. I think that's a reference to Schrodinger's box, another great channel on YouTube. But we're going to go to the whiteboard. I'm going to kind of draw this circuit myself to get everything on the same page to make it a little bit more clear for you guys to understand what is going on here. And we'll then begin to focus more on this wiper motor assembly as the cause for this radio staying awake. Yeah, pretty wild, pretty crazy issue. But let's get to the whiteboard. Let's do some circuit analysis on this so that we have a better idea as far as what's going on and how this wiper motor unit is affecting this board. Alright guys, so what I've done here is I've basically drawn this entire unit, just kind of summarized and compressed into exactly what we're dealing with here. And we'll just briefly go over this so you guys have a better idea as far as what we're dealing with here on this circuit. So we look up here, what I've drawn here is the ignition switch. We can see that it receives battery voltage here. And we can see that in the accessory position here, this switch is going to close. And it's going to send voltage black with light green wire in the direction of this generic electronic module here. We can see internal to this module, we have this fuse number 3 and this fuse number 7. This fuse 3 is the one we pulled out, guys. This is the one that we were able to eliminate this backfeed voltage from. And if we follow that, that goes down to the wiper motor. What I believe is happening internal to this smart junction block is there some sort of ignition input sensing circuit here. I've drawn that right here. Hopefully you guys can see that. So this little module here, it's going to be tied into this black with light green wire fed from this ignition switch. And basically all it's doing is it's watching this for voltage, the presence of voltage. When this chip or whatever is monitoring this circuit detects sufficient enough voltage on this, it's going to interpret that as that the key is in the accessory position. And based off of that, it's going to energize the accessory delay relay, which turns the radio on, as well as the windows and stuff like that. So we took a voltage measurement here, guys, and we had 2.8 volts. What we then proceeded to do is we just cut this wire. We cut this black with light green wire. We eliminated the ignition switch from the equation, and we still had this 2.8 volts present. What we then did at this point is we took a harder look at this generic electronic module to determine what circuitry internal to this unit this thing was actually hooked into. And what we found was that it was externally connected to both the rear wiper and the front wiper. So what we did at that point is we pulled this fuse out here. This fuse number 3, 10 amp fuse. So we pulled this fuse out, guys. And what we saw is our meter went to 0 volts. And really what that tells us is that this 2.8 volts here that's being backfed into this circuit internal to the board of this generic electronic module, it's coming from this front wiper motor, guys, no doubt about it. This wiper motor, for some reason, there's something going on in this circuit. It may not be the wiper motor, it could just be this circuit going up to this fuse number 3. It is sending 2.8 volts in this direction. And what's really going on here, guys, is this 2.8 volts is sufficient enough for this chip to determine that this ignition switch is on in the accessory position. It's definitely not any sort of load-bearing circuit, at least as far as this input goes. It's definitely just some sort of switch input for this unit to determine that this ignition switch is on and in the accessory position. So really what we need to do next and what we need to focus on is we need to go to this front wiper motor unit. It's a little tough to access on this thing, guys. You got to pull kind of the wiper cowl out and stuff like that. I'm going to do that off camera for the sake of time. And we need to do some checks here at this wiper motor unit, determine where this voltage is actually coming from. And potentially we're looking at a faulty wiper unit. We could also have a high resistance copper to copper short in this wire. I find that pretty doubtful, guys. But to kind of summarize as far as what's going on here with this unit, I'm just going to draw a graphical voltage representation here. We'll say that this is 12 volts. We'll say that this is 0 volts. This imaginary line I'm drawing here, guys, this is a threshold line that this input monitor for this generic electronic module is looking at it regarding ignition switch position. And what I think is going on here is this GEM, this generic electronic module, it's looking for voltage to cross a certain threshold to determine if this ignition switch is on. Given that we have a flat line 2.0, what I basically think is going on is we're above this threshold that this thing is looking at regarding this input. Really, this GEM is looking at this ignition switch on when it is not, due to this very small amount of voltage is being backfed into this circuit. So anyways, next up, guys, I'm going to get this wiper motor pulled out. We're going to do a visual inspection first, and then we're going to do some electrical tests there to where this 2.8 volts is coming from, whether this wiper motor is potentially shorted or something like that. So let me get the wiper unit out, and then we'll do some checks there. Alright guys, so as you can see, basically all I've done is I've just kind of pulled this wiper cowl unit out of here. A little bit involved, not too bad. It takes about, maybe 15 minutes or so, a bunch of bolts, a bunch of push pins. But really what I want to show you guys is I want to show you the backside of this wiper motor. And we can pretty clearly see we've had some wiring repair going on here. Someone's definitely been messing around with this connector. Definitely pretty crazy, definitely pretty strange. I'm not sure if the wiring itself is our issue or not. What I have here is I have my meter coming from that black light green wire that we cut inside. We can see we have 2.68 volts. So I'm kind of thinking initially, just to see if we have some sort of wonky wiring stuff going on, is I'm going to get you guys focused on the meter, and all I'm going to do is I'm just going to kind of gently flex this harness around at this location that something was done, and we're going to watch the meter while we do that. So just keeping an eye on the meter, and I'm moving this wiring, and we can see that this voltage is definitely fluctuating. This is definitely pretty wild, pretty crazy. See if I can just kind of squeeze it in the right spot. I mean, we can definitely see that it's fluctuating around. I had it drop pretty low there for a little bit. We see down to 1.8 volts. So guys, there's something wonky going on with this repair, quote unquote, that was done to this. So what I'm going to do is I'm going to unplug this connector. I'm going to get all of this tape off of this thing. I'm going to see what the hell is going on as far as the connections of this go. Alright guys, so what I figured we'd do here is we'd unwrap this little present together. I'm just kind of taking an initial look at this connector here. And one thing I can see is I have a broken wire here. I'm not sure if that's supposed to be connected to anything at all. Let me make sure that you guys can see that pretty well here. I'm just kind of playing with this wire right here, guys. Maybe I'll get you focused in a little bit closer. See, I'm trying to get you guys propped up on the intake manifold. It's a little difficult. There we go, that should work. So we're just going to unwrap this, guys. I'm definitely suspicious that we have some sort of short going on here. So I'm just pulling this electrical tape off of this. And one thing I can say is with this unit unplugged, guys, I no longer have voltage on this pin in here. And I'm not sure what sort of connectors were used for this. It looks like, I'm not sure if these were soldered. And it's got some kind of strange heat shrink on here, guys. Just kind of pulling all of this stuff back away, and I can already see it. I can already see it, guys. So what I have here, let me find it again, right here. I have a large wire here. The insulation is broke through, and I have open copper here, guys. And I also have some open copper here at this connection. Hopefully you guys can see that pretty well on the camera. Let me make sure that you guys can. But the one that I'm mainly talking about here, guys, is this very large wire. Looks like a pretty heavy power feed here. Looks like a black wire. Let me see, I'm just kind of looking through some of these other ones too, guys, to see what else we have. I also have some wiring here that's exposed. Really, there's quite a few of these connections, guys, that are just completely open to the air. I mean, there's copper hanging out of them everywhere. So this large one that we had here, guys, the large one, it appears to be a black wire on the harness side, a black with white. Looking at some of these others, just kind of finding some of these others that are open. This one right here looks to be like a white wire. It's a smaller gauge. There's exposed copper on both sides and a little bit of corrosion going on here. So we have a white wire that's exposed. We also have a heavy gauge black with white wire that's exposed as well. We also have a, let me see, there's a few of them, guys. This is a really bad wiring repair, whoever did this. I'm not sure why this was done. Oh yeah, black with white wire exposed, white wire exposed. Really just, man, this is just a mess, to be honest with you. And really what's going on here, guys, is we have a copper to copper short in this harness, in this connector of this wiper motor. That's what's keeping this accessory delay relay energized. That's what's keeping the radio on. That's what's keeping the windows working. So now that we know what circuits are affected on this, let's go back to the diagram and identify these on the wiper motor circuit and see what exactly they are, so we can piece this whole story together, and that way it really makes sense. Alright guys, so I've taken another look at this diagram to see what color our wire was here. And it's this dark green wire here. This is the one we had the 2.8 volts from, so this is the one that's being backfed from this wiper motor unit. I've just taken a look kind of at this harness here, and I've identified this wire. It's this one right here. Taking a look at this one, guys, this isn't one of the wires with exposed copper. And really what would need to happen is this would need to have some sort of high resistance short to this red wire, which is the other power feed, this heavy gauge red here. So it's unlikely, even though we have all of this really crappy wiring done here that needs to be fixed, it's unlikely that a copper to copper short is what's actually causing this. So what I then wanted to do is I wanted to look at the motor, and I just unplugged this, and this connector is completely corroded out, guys. There is a ton of corrosion in here. If we look down into the wiper motor connector cavity, we can see there's also some kind of standing moisture in there, and many of these pins are corroded out. There's definitely some damage to this motor that's been done. So as far as our short location goes, I believe it's taking place internally to this motor based off of this corrosion and the water intrusion that we have here. I do not believe the wiring is the actual fault here, even though that it really needs to be fixed, because this is truly terrible. But really what it appears happened on this, guys, is we had some sort of water intrusion into this wiper unit, and this corroded this connector out. It also did some damage internal to this wiper motor, and really there's kind of only one answer to that happening. We have some sort of water intrusion going on in this cowl area, and it's not going away. It's not being drained properly. So what I've done is I've just taken a look at this this little thing right here, and what I believe that this is this is the drain for this wiper cowl unit. I think this is what actually gets rid of water. I think it just goes to the bottom of the car down there. So what I'm going to do is I'm just going to pull this out and see if I can get a look down there and see if there's anything in there, maybe blow it out, and that'll really kind of point us in the direction that this thing is clogged, and that's what's causing this condition. Alright guys, so based on the corrosion here, what I did was I removed the little elbow going to this drain here, and I actually pulled this drain thing out and looked through it, blowed through it, made sure it was not restricted. There was nothing in there. So I'm kind of just trying to backtrack in my thought process and determine what the cause of this condition was. We know that this connector was replaced. So what I did was I pulled some history on this vehicle to see if any work had been done in the past on it, and it appears that this connector was replaced about a year ago. The initial complaint that they were having with this was the wipers were not working. This connector was replaced for that. I'm not sure who did the connector. I'm not sure, what was found. But what I'm going to assume was found on this, guys, is whoever was troubleshooting this thing found corrosion in this connector, and they replaced it based off of that. I think that the drain was maybe cleared at that time to make sure it was not clogged, but what was not replaced was the motor. And I think that the corrosion in the motor had already started, and what I really think happened was that it's kind of started to spread to this wiring here. Obviously all of this exposed copper is definitely an issue too, but as far as the fix goes, what's going to need to be done with this unit here, guys, this motor needs to be replaced and this connector needs to be re-replaced at this point, and this wiring needs to actually be repaired properly now. This is definitely not a satisfactory wiring repair. Tons of exposed copper here. As I said again, based on the manner in which this was shorted, I do not believe the wiring was the cause. I believe that the short is actually inside of this motor unit due to all of this corrosion. So kind of to confirm the fix, I've already unplugged and plugged this back in a few times, and I still got my meter hooked up inside of the car here, guys. As we can see, we have this 150 millivolt number. No problem there. That 2.8 volts is no longer present since we unplugged this motor and plugged it back in a few times and separated all of this wiring. Just to go back inside of the car here, as you can see, the windows still do not work. The key is still out of the ignition, and we can also see that the radio is off. So really what I'm going to do, guys, just to sort of confirm the repair before we do the repair, because I doubt that I'm going to film the after on this. I'm probably just going to fix this stuff and get it out of here. I'm kind of tired of looking at this thing at this point. But just to show you guys that this is in fact the issue, as we can see, that voltage is no longer present on this wire. 150 millivolts there. We are on the smart junction block side of this. When we turn this key on, we should see battery, or we should still not see anything on this. Let me make sure my connections are good, actually. Hold on. Yeah, so currently have the key on, guys, and we still don't have any voltage present here. The reason being is because obviously we cut the wire down here. So what I need to do is I need to repair that wire real quick, get that reattached. I'm going to do that real quick off of camera, and then I'll take you back through the system and I'll show you that everything works normally now as far as this radio shutting off and all that good stuff. So I'll be back in 1 second. So here's the repair, guys. All I did was I used a heat shrink butt connector. This is the good kind with the adhesive on the inside of it. As you can see, we're still tied into the circuit here, guys. This is coming from the ignition switch. Basically what we're going to do now, guys, is we're going to do a pre-repair confirmation of our diagnosis here. Since we have unplugged and plugged this washer unit back in, we no longer have that 2.8 volts there. We disturbed whatever sort of short was going on in that unit. So some initial views here, guys. I just have the key on. You can see the radio's on. I'll actually turn the volume up a little bit so we can hear it. So I'm just going to cycle the key off. We can see the radio is still playing. I've got the key out of the ignition. We no longer have voltage on this, guys. Remember, we had 2.8 volts here before. So ideally on a good system, what should happen is when we open this door up, this radio is going to shut off. As you can see, the windows also still currently work. So we're just going to open the door up. What should happen is this radio is going to shut off. So open the door, radio did shut off. Try our windows again, they no longer work, and as you can see, we no longer have that 2.8 volts present on here that was being backfed from this shorted, corroded wiper motor. So that's a confirmation of our diagnosis, guys. Without a doubt, this wiper motor is what was causing this condition. Again, we'll just do that one more time just to show you. Putting the key back in here. And I'm actually going to turn this to the accessory position first, and we'll watch voltage here. As you can see in the accessory position, we have 12.3 volts. We're also going to have volts here in the run position. As you can see, turn this back to off, key out of the ignition. We no longer have voltage present here. Our radio's on, open the door, and the radio goes off. So, that's a good confirmation there, guys. Again, the fix for this, we need to replace this wiper motor. We need to replace this connector and wire this thing back in here properly. But it was a pretty wild one, pretty crazy one. When we first went into this, we sort of identified where our issue was pretty quickly, and we began focusing on that accessory delay relay. We found that it was being controlled by the smart junction block. We did some digging to find out what sort of inputs were involved in that, what was involved as far as what actually told this junction block to turn that relay on. We came to the conclusion that it was an input from the ignition switch in the accessory or the run position. So we did a voltage measurement there. We found 2.8 volts. Initially, I did not think that was sufficient enough to really do anything, guys. I kind of thought maybe this is some sort of bias voltage that this unit's sending out for some sort of short circuit detection or anything like that. So we kind of skipped past it and went over it initially. The next thing we did is we did powers and grounds checks on the smart junction block, and we found that they were all good. So at that point, guys, I was starting to lean pretty heavily towards this module being defective, but something just didn't quite sit right with me based on the fact that we could ground that 2.8 volts out, and this accessory delay relay was being de-energized and everything on the vehicle was being shut down properly. So we kind of did some more checks as far as that went. We had to look at a few different diagrams and kind of piece the whole story together as far as what all was involved in that circuit that we were tied into. And what we found is that it was a shared, externally with the wiper motor via two other fuses downstream of that in the circuit. So after seeing that, guys, we basically went to the wiper motor. We found all the damaged wiring. We found the corrosion. And really what was happening here is this wiper motor was shorted internally. It was back feeding 2.8 volts into this circuit. That 2.8 volts was sufficient enough to meet the switch input state that this module was looking for as far as determining where the ignition switch was. That 2.8 volts was enough, even though initially I thought it wasn't. So this was a pretty crazy one, pretty complex one, guys. This is definitely a tough thing to figure out in the field. Total time in this vehicle, including bringing you guys along, I'm about 3 hours into it. If I were doing this one by myself, guys, it would probably be about an hour and a half. diagnosis or something like that. I'm sure there's people out there that can figure it out quicker. But the most important thing is that we did come to the correct conclusion. We definitely figured out what was wrong with this car. Again, pretty crazy issue. Not something you're going to see often. Not something you're going to see every day. But I was definitely super happy that I got to bring you guys along. Typically I can't because some of these are just so long. But I really wanted to make it a point to get you guys in on this one. And I don't know if this is a common issue with these Freestars, guys. I don't know if these drains clog often and cause this condition. I think that's what probably initially set all of this in motion, was that drain at some point was clogged up, water got in there, and began corroding that motor out. And you know, someone was in there, someone has replaced this connector in the past about a year ago. So it had corroded out. I'm sure that was probably why it was replaced in the first place. But anyways, we learned some good lessons on this. Definitely don't jump the gun when you're talking about calling a module, guys. There's a lot of stuff involved with it. You know, whenever I'm dealing with something this complex and I'm thinking about making that call, I'm always trying to think of, what did I miss? Is there anything else involved here? And that's really what kind of pointed us back to the diagrams to take another harder look as far as what all was involved in that circuit. And that's when we truly found the cause of this, guys. So 2006 Ford Freestar, erratic wiper operation, stuck on. Radio stays on, power windows continue to work even with the key out of the vehicle. Cause for all of this, shorted windshield wiper motor. And yeah, don't know if I'll ever see it again, but I'll definitely keep this issue in mind. So thanks for following along, guys. This is the end of part 2. This is the last part. I'm not going to film the repair. I think that you guys have seen enough information to be confident in our diagnosis and what I'm telling you. So I'm going to fix all this stuff off camera and get this thing back on the road. Thanks for watching, guys. Thanks for sticking along with me. This was a super fun one. Glad I could get you guys involved in it to see, you know, just to see where this one would go. But this was Triangle Diagnostics, guys. That's what we do here. I do my best to show you what's going on with these cars and bring you through the entire troubleshooting process and my thought process that goes into it. So any questions, let me know. But that's it for this one, guys. Thanks for watching.